Hello everyone, once again I welcome you all to MSP lecture series on transmetal chemistry. This is 25th lecture in the series. In this lecture I shall give you the preparation of important and useful metal complexes, keeping the catalysis and also further interesting organometallic compounds in mind. So, let me begin with some compounds of palladium. So, for example, if you just look into platinum metals such as ruthenium, palladium, platinum, gold, rhodium, iridium, these compounds are quite extensively used in homogeneous catalysis for a variety of organic transformations. Then how to make some of these compounds and what are the properties of these compounds that can be used as precursors for further substitution and making desired compounds with desired ligands to guide the reactions in the name of homogeneous catalysis. So, you cannot use any complex that comes to your mind for catalysis. Well defined ligand should be there and well defined metal should be there, and also precise oxidation state has to be chosen and such compounds has to be chosen, and what kind of coordination number should be there to begin with, and once if one or two ligand leave or dissociate, what kind of compound we are going to get, whether that can be a catalytic precursor or not. So, all those things we have to keep in mind, and when we keep all those things in mind and we come up with an excellent ligand system, and then we need an appropriate metal precursor for further substitution reaction to make the desired compound. Simply you cannot use any compound. From that point of view, I shall give you the preparation of very important compounds. Let me begin with palladium cod chloride. You must have heard about palladium cod chloride. So, cod is cyclooctadiene, it is very easy to write. It is a diene bidentate ligand. So, this is cod cyclooctadiene. Then how to make this compound? The starting compound is palladium chloride. You take palladium chloride, and palladium chloride if you take as such, it is insoluble in organic solvents and also it is insoluble in water. As a result, what you should do is you add HCl. Once you add HCl, it forms palladic acid, something like this, and this is soluble now. So, this is the first step. Take anhydrous palladium chloride, add HCl and then generate this species here. Once of generating this species, treat this one with C8H12. So, this is C8H12. Of course, this reaction does not need any heating or anything. This reaction can be carried out at room temperature in ethanol. So, you should remember in future if I write RT means it is room temperature. What we get is if you are curious to know the structure, this is how the structure looks like. This is palladium cod chloride. This is very useful. For example, you take this compound, let us say treat with 2 equivalents of triphenyl phosphine in dichloromethane. These 2 triphenyl phosphine molecules would replace this bidentate ligand, then we get a compound like this. So, this cyclooctadiene being a diene has a characteristic smell, and this compound does not have any smell, but the moment you treat with 2 equivalents of triphenyl phosphine and then this cod is liberated. When the cod is liberated, you can see the smell coming, characteristic smell of olefin comes out. So, that indicates that reaction is progressing, and also there can be color change. This is a bright yellow color and this will be slightly yellow or even pale yellow color. So, visually you can monitor, and also if you are careful you can also through smell you can make out that reaction is progressing. Of course, once this compound is made, you can crystallize and take NMR, and NMR should show a single phosphorus resonance indicating this one. And in case if there are two isomers are there, then you should be able to see two chemical shifts, 31p chemical shifts indicating cis and trans isomers. So, with this reaction usually you get a cis isomer. So, this is the utility, and not only this one, if you want to use any other ligands, bidentate ligands, you should be able to use conveniently starting from palladium cod chloride. So, another important compound is bis benzonitrile compound. So, here this is very similar to the previous one. Instead of cyclooctadiene, we are using PHCN ligand here. This is a nitrile. So, this lone pair is there, this lone pair goes to the metal. That means this forms a very weakly coordinated compound, and but moderately stable bright yellow powder we can handle even in atmosphere without any problem. So, how to prepare this compound? Take this palladium chloride here and add excess of and reflex, you get this compound here. Of course, one can also write like this fashion, but it is always appropriate to write ligand in such a way that the donor atom is facing the metal center. This is not correct, okay. One should write something like this. This is also very useful compound. In this case also you take again a bidentate ligand. Consider for example a bidentate ligand such as this one. This is called bis diphenyl phosphonomethane. It is a methyl derivative. This is a bidentate ligand. You take this one and two benzonitrous will come out and you get a compound like this, a chelate compound. So, this is how one can make some of these very labile metal precursors, and conveniently without losing this compound or further decomposition you can get quantitative yield of compounds depending upon what kind of ligands you are using. And if acetobenzonitrile is not available, it should not be a problem. You take this palladium chloride and take dry acetonitrile, freshly distilled acetonitrile or methyl cyanide, and excess, reflex it for about 2 to 3 hours, you will see the formation of bright yellow colored solution that is due to bis acetonitrile complex formation. This compound is much more unstable compared to benzonitrile. As a result, whenever we need, this can be generated in situ, and without isolating one can use it. If you want to isolate this one as bright yellow crystals, it has to be stored under nitrogen in airtight bottles. So, this is another important precursor, and sometime what happens, there is no need to isolate this one. Take palladium chloride and reflux in dry acetonitrile for 2 hours, and then add ligands, whatever the ligands you want to add, and substitution would be complete, and you can quantitative conversion of bis acetonitrile compound into corresponding compounds. For example, you take here, add, you can get this compound. So, like this. So, these 2, 3 are very important compounds and very easy to make. Commercially if you try to buy, they are very expensive, but on the other hand palladium chloride is little cheaper and one can conveniently make these compounds, and also even yields are quantitative. So, you start with palladium chloride, and since you are increasing its molecular weight by 2-fold, you can see start with 1 gram you can get 3 to 4 grams. So, that is the advantage of learning these preparative methods to prepare in your own laboratory instead of buying all those things commercially. Next, consider one more compound. This is tetrakis triphenyl phosphine platinum compound. This is one of the very useful platinum 0 compound here, a D10 system, and D10 system means you should remember that it has tetrahedral geometry. Similarly, one can also make palladium compound. This is most useful palladium 0 compound. This is an 80 electron species with D10 in homogeneous catalysis, and it is commercially available. Many reactions, carbon-carbon cross coupling reactions or hydrogenation and many other reactions, people use this one, and this compound can be made again easily. So, let us look into first platinum compound preparation. For this one we are using potassium tetrachloroplatinate, that is K2PtCl4. Take this one, add 4 equivalents of triphenyl phosphine in presence of alcoholic KOH, that is for reduction purpose. And this has to be heated to 60 degree centigrade. Remember, temperature is very critical, it should not go beyond 60 to 62 degree centigrade. If it goes beyond, what happens, the yield will reduce. So, take a mixture of potassium tetrachloroplatinate, 4 equivalents of triphenyl phosphine in presence of alcoholic KOH. What you get is what are the other byproducts, I am writing them also. So, this is the balanced equation for the preparation of tetrakis triphenyl phosphine platinum starting from potassium tetrachloroplatinate. Another important compound of platinum metals is ruthenium complexes. Okay, ruthenium is in +2 state here because 2 anionic ligands are there, one is Cp, one is chloride. Then how to make this compound? For most of these compounds we use trichloride trihydrate. You should remember, in case of iridium, ruthenium and rhodium we are using +3 compounds, MCl3 3H2O, they are ideal ones, and in case if they have NH2O, using an appropriate method you have to generate first anhydrous salts and then you make the trihydrate compound. These trihydrate compounds are quite reactive and convenient to prepare a series of interesting organometallic compounds and also coordination compounds which can be further used in various applications. One such important application is again homogeneous catalysis. For this one, for the preparation of this ruthenium 2 complex having 2 triphenyl phosphine and 1 cyclopentadienyl group and 1 chloride, one has to start with ruthenium trichloride trihydrate. Okay, and take 2 equivalents of cyclopentadiene. So, this should be freshly distilled. Okay. So, for example, if you take cyclopentadiene and if you keep it at room temperature for a prolonged time, so it undergoes dimerization to form cyclopentadienyl dimer. So, this dimer has to be cracked into monomer. Simply by distilling it, you can convert into monomer. Immediately you have to use it, that means you have to generate quickly, you have to distill quickly and then you have to use it. Otherwise what happens, you will end up with a dimer and that does not react with this metal precursor. So, take this one and treat this with 5 equivalents of triphenyl phosphine. So, take ethanol and reflux it. So, you get this one, along with this you also get for this purpose what we are doing is we are using excess of one equivalent of triphenyl phosphine that leads to the formation of phosphine oxide, and this acts as a reducing agent here. And one thing you should remember, one can write something like this, there is no harm, but to be precise, when we have these aromatic groups with different hapticity, it is always ideal to write that ligand in the front. So, best way to write is in this fashion. This is the correct way of writing. So, this is also useful compound. For example, in this one can also replace two equivalents of triphenyl phosphine with a bidentate ligand, because entropically that is a favored one with chelate ligand. So, you can replace this one, or if you are using excess, what happens, you can use a polar solvent so that you can ionize RuCl and it becomes cationic compound. So, if you use non-polar solvents, you can simply substitute 2-triphenyl phosphine with the desired ligands, bidentate ligands or monodentate ligands, which are better sigma donors compared to triphenyl phosphine. Or if you want to use slightly excess to even get rid of chloride, you have to go for polar solvent. For example, take this compound and add 2 equivalents of bidentate ligands. Let us say I am adding 2 equivalents of DPPM. DPPM is diphenyl phosphonamethane, I used it in previous palladium complex. So, use this one and in methanol, and if you reflex it, basically what happens, it becomes ionic complex. Okay. And then you have eta 2 DPPM and eta 1 DPPM, and then you have chloride here. So, something like this happens. How this molecule looks like? You can see here in this one 2 ligands are there and chloride is here, it becomes an ionic complex. So, one can make it, and how to know that this has 2 ligands, one is a monodentate ligand, one is a bidentate ligand. 31P NMR would tell you again. If you look into 31P NMR spectrum of this complex, 3 signals it should show. For example, these 2 are chelated, so they will be coupling with this one to show a triplet, and then this would be coupling with this one as well as this one, depending upon which one is larger. Either it can be a triplet of doublets or doublet of triplets, and then this is very far from this one, it may not couple with this one, simply it can show a doublet. And assignment and interpretation will be very easy, and one can easily know simply by recording 31P NMR spectrum whether you made your compound or something else has formed. Of course, once these lectures are over and most of the aspects that I want to discuss are completed, I shall give you some hints about 31P NMR and how to understand interpretation of data using various multinuclear NMRs. So, now let me give the preparation of another interesting compound of ruthenium. This is also very useful compound. How to prepare this one? In the same way as I described for the previous one, starting with RuCl3 3H2O. Here simply we are taking excess of triphenyl phosphine and reflexing this mixture in ethanol, that leads to the formation of a ruthenium 2 compound. Plus so, here the role of excess of triphenyl phosphine we are using is to act as a reducing agent. So now let me tell you about a couple of rhodium complexes, rhodium 1 complexes to make Wilkinson compound similar to Wilkinson compounds or other bisphosphine bound complexes of rhodium plus 1. Okay. So these two precursors I am going to write are very important. So that is for the first one is rhodium cod dimer. If you are curious to know the structure of this one, this is how it looks like. This is rhodium chlorocarbonyl dimer, and of course, if you can see here when we do reactions, it symmetrically cleaves in this fashion to generate immediately a coordination site, and then that coordinate site can be occupied by appropriate ligands, and if you further force a reaction using drastic conditions, you can also eliminate cod here and in its place another 2 ligands. That means 4 electron donors can come into the picture. So that means it is quite versatile. Either it can retain chloro bridges and substitute for cod, or it can also break symmetrically to generate a vacant coordinate site on each rhodium, and also it can be substituted. So 2 options are there while using this one. Then how to make this compound here? Here again we are taking rhodium trichloride trihydrate. Okay. And then we are using cyclooctadiene, and then we are using ethanol as a solvent and also as a reagent, and we are using sodium carbonate, a base. It is a dimer, already I have written the structure here. So this is how you can make this rhodium chlorocyclooctadienyl dimer, very useful compound this one, and also from this one can also generate chlorocarbonyl dimer also, or one can also use another method of directly reacting rhodium trichloride trihydrate with carbon monoxide. A very interesting reaction, you can perform solid state reaction. I shall tell you details about the preparation of that one and also how to further react this to get some important derivatives I shall tell you in my next lecture. Until that, have an excellent time reading chemistry.